All right, AP Statistics students. So we're getting ready to start the two sample t-test. But before we do that, it would be a really good idea to just review the process for the two proportion z-test, which was on the previous test. Because, of course, the two sample t-test is just completely analogous to the two proportion z-test. So if you remember, state, plan, do, conclude method for the two proportion z-test. Let P1 equal the proportion of this population and let P2 equal the proportion of this population. That is the two populations that you're about to compare. So you have to define two parameters. Then your null hypothesis is always population 1 equals population 2. They're the same. And the alternative can be P1 not equal to P2 or less than or greater than, depending on what you read in the problem. So that's your state phase. Then you go to the plan phase, which is check the conditions. And so these were the conditions for the two proportion z-test. Both samples must have been randomly selected, duh. Both sample sizes must be less than 10% of the respective populations to ensure that they're independent. And for both samples, the observed number of successes must be greater than or equal to 10. The observed failures must be greater than or equal to 10. And then the conditions for the two prop z-test have been met. Okay, then you move on to the do phase. And the do phase is get both of the sample proportions, P1 hat and P2 hat, get those values, and then subtract them so that you get the difference between them so that you're comparing them. And then remember, we had this very quirky P hat pooled, which your calculator just calls P hat, that you have to calculate. And then you have to take the standard error of P hat, which is the pooled P hat value, the square root of the pooled P hat value times 1 minus that, divided by the first sample size, plus the pooled P hat value times 1 minus that, divided by the second sample size. Remember, you have to play the game. You have to calculate that number because that's what you need to divide by to get your z-score. So remember, your z-score is equal to the observed difference minus 0 because that's what we were expecting the difference to be, divided by the standard error. So it's called a z-test. They want you to calculate z, so you have to play the game and have that standard error calculated. And then, of course, you draw your picture and you get your p-value, and then you draw your conclusion. And you know how to draw conclusions by comparing the p-value to the alpha level. So you didn't really need to take any notes on this first slide. Now, we're going to move on to the real handout. For those of you who are out of town, I should have shared this document with you. You could pull it up and write on it or print it out if you have a way, or just look at it with me. So this is the two sample t-test, state, plan, do, conclude. Okay, so the state phase, let mu1 equal the mean of this population and let mu2 equal the mean of this population. Completely similar. The null hypothesis, mu1 equals mu2. The alternative, mu1 does not equal mu2 or is less than or is greater than. That state phase should just be very familiar to you. Now, the plan phase. These are the same conditions for the one sample t-test. These are the same conditions for the one sample t-test. It's just that you have to do it for both samples. So, both samples must have been randomly selected from both populations. Both samples must be independent of each other. So, in other words, you're comparing two populations that should be independent of each other. So, you have to make sure that the two samples themselves are independent of each other. But notice this great big and. Both samples must have independence within themselves, which is usually found by the 10% rule. So basically, what that means is this. Let's say that I had these two groups. We'll call this group 1 and this group 2. If Steve is in this group and Steve's sister is in this group over here, well, then the two groups are not independent. So you couldn't use a two-sample t-test there. Okay, so that's one thing, is that the two groups must be independent of each other. But here's the other part. Not only do the two groups have to be independent of each other, but also consider this. What if Steve's sister was in the same group as Steve? Then that's not good either. So you can't have relatives in each group, and you can't have relatives within the same group. So when you're checking for the independence, you have two things. The two groups themselves must be independent of each other, and the people in each group must be independent of each other. And you can usually do that part with the 10% rule. And then, of course, the third condition is, ideally, if both sample sizes are greater than or equal to 30, that's great. But if not, if you have raw data, graph it and show me that there's no strong skew or outliers. Or if the problem just states that both populations were normal or symmetric, then you're typically okay. Moving on to the do phase. You have to calculate the sample, the mean of each sample. Then you need to subtract the two means to get the observed difference. And then you have to find the standard error of x1 bar minus x2 bar. Now, you'll see on this handout, I've actually given you the formula, but I want to take you back a few chapters and explain this formula to you. Just watch this. Do you remember? Probably not. Way back when in chapter 6, we learned that the standard deviation of a random variable x1 plus a random variable x2 is equal to the square root of the variance of the first one plus the variance of the second one. And even if that was a minus sign instead of a plus sign, the formula was still the same. So that was way back in chapter 6. The standard deviation of x1 minus x2 was equal to the square root of the variance of x1 plus the variance of x2. Okay, now, in the chapter 9, in the one sample t-test, we learned that the standard error of x bar is equal to s over the square root of n. Yes? Okay, so watch this. If I'm looking for the standard error of x1 bar minus x2 bar, then that would be equal to the square root of the variance of x1 bar minus the variance of x2 bar. Well, that would equal the square root of s1 squared over n1 plus the square root of s2 squared divided by n2. So just to explain this, you see that crazy looking s2 with a 1 there? Okay, remember s squared means variance and the 1 means sample 1. So in other words, s1 squared is the variance of the first sample divided by n1, and then plus S2 squared, that's the variance of sample 2 divided by N2. So it's a formula that I've just given, but it can be understandable if you look back at some of the old stuff. So definitely wanted to kind of go there with you. Now, after you get your standard error, all you got to do is calculate your t-score, which is equal to that observed difference minus 0 divided by that standard error. And then you draw your nice, lovely t distribution. You label the middle 0. You label this with the difference between the two. And this is going to be your p-value. And you're going to draw your conclusion. So, state, plan, do, conclude for the two-sample t-test. Now we're going to look at, on the next video, the next handout where I'm just going to go through an example with you, and then on a separate video, a second worked out example with you.